Alright, hello there everyone. We're going to go ahead and check out some negative, square root of negative ones. So just to make sure that you guys are remembering the basics of this, is how it is that we start with this is the square root of negative 1 we define as equaling I. So if I want to talk about what is I squared, then that means that I need to take I and square it. And squaring something and square rooting something are kind of doing the opposites of each other, so they kind of undo each other, which means that I squared is equal to negative 1. If you know this fact and this fact, you can solve everything. So it all boils down to just those two facts there. So, looking here, we're going to do number 3. For number 3, I do need to deal with the 72 as a square root, but I also need to deal with the negative. The negative just simply becomes an I. So now what I'm really dealing with, so what I really did is I split it up as root negative 1 and root 72. But now I need to split up root 72 as perfect squares. So a perfect square that goes into 72 is 36, and that is times 2. So 36 is really 6. Root 2 can't change, so it stays just like that, and this would be the answer. You never put the i's, you never put anything after the square root, because then it's misunderstood, like was it under the square root, was it not? So this would be the answer that we would write. Let's go ahead and look at number 5. Number 5, again, you have your negative 1, and then you have your 228, which can be 144 and 2. And if you didn't know that, you can always just say, well, 4, try 16, try some other numbers and see if you can start breaking those things down. The 144 is the 12, the negative 1 is the I, and the root 2 stays as the root 2. Let's go ahead and look at this one here. So I already have my 2I, but then my negative becomes, so I have a negative 1, a negative 4, and a negative 2. So 2 times 4 is my 8. Why do I want that? Root 4 is a perfect square. So this becomes an I, root 4 becomes a 2, and then I have my root 2 here. So at this point I do need to simplify some things. I have my root 2 here. I have 2 times 2 is 4. But I times I is I squared. So we go back to what we talked about here. I squared is really negative 1. So I'm going to put a negative there. Now that kind of looks icky, so I'm going to rewrite it because it really all just is one term there. Alright, let's look at a different looking one, 9. I'm trying to do one of each of the types that we might be looking at here. So we have negative 4, negative I times a negative I is a positive I squared. And I squared again is equal to negative 1. So all of that mess there is equal to negative 1, and multiply it by negative 4. We end up getting a positive when you multiply those, sorry about that. You end up getting a positive when you multiply those two answers, so that's just plain old 4. Now let's look at 10. 10, I to the 4th squared is I to the 8th, because you have I to the 4th times I to the 4th, so I have a total of 8 of them, which is really I squared times I squared times I squared times I squared. That's one way to look at it. Or you could say I squared to the 4th power. Now, either way, each of the times that you have your I squared, that's equal to negative 1. So I either have negative 1 to the 4th power, or negative 1 times negative 1 times negative 1 times negative 1. Either way, every time you have a double, they end up being positive, because a negative times a negative is a positive. So here I have an even number of negatives, which would make the answer a positive. Last but not least, we have this. Now I want to go ahead and do 2 cubed, which is 8, and I cubed, which is I cubed. And the reason is that is 2I times 2I times 2I. So that gives us that. 8 and 4 reduce to give us a 2. And I reduce one of those, which gives us I squared. Remember, I squared is equal to negative 1. So we have 2 times negative 1 is negative 2. Now, try the rest. See what you can do.